At the close of the last video in this series, I said that we were going to go ahead and test that capacitor on the capacitor tester. And here's how that went. Well, we managed to get it hooked up, so we need to go ahead and do a capacitance check on this. I had to kind of jury-rig the leads around a little bit to get it to hook up. Anyway, she's hooked up, and I didn't have to disconnect it from the 1K resistor. And you know, there's the eye tube, and the idea here is to get the widest spread possible, which I have, and you do that by adjusting this knob right here. I adjusted it back and forth until it finally became wide. Let me see if I can give you a little show here. There we go. See how it closes up and go back the other way. All I'm doing is turning this thing back and forth, and you'll see the eye tube get real wide and then close after it gets to a certain point. Right there, I think, is about it. Now, according to the button I have pressed here, we're supposed to read C5, which is the this button here takes care of 1 to 100 picofarad capacitors, by the way, and C5 is the red scale. I'll read it, which is 0 to 100. So we'll go ahead and see what we've got here. Let's see if I can get a little zoom for everybody to see what the capacitance is. It is 2, 4, about 55 or 56 on that red scale right there. Okay, there's 0 on up, about 55 picofarads. Let's see if I can get it to adjust a little bit more. See if we can get it really close here. Let me see. $52, $54, 2, 4, 6. Looks like about 57 picofarads, you know, but there is a little bit of a tolerance on this thing either way, you know. Well, we got the capacitance check done, so let's go ahead and take a look at the resistance check. I got all the switches and everything set up according to this paper, and what we need is 5,000 or higher, and it'll mean that the capacitance, the capacitor resistance is good to go. Let's see what we've got here. 5,000 or higher. Look at there, way above 5K. Way above 5K. Okay, we're good to go on resistance. I'd say this capacitor is actually good. But you know, I'll probably wind up changing it anyway. We'll go ahead and test this 1K resistor also. 1.05, 1.06. The resistor's good. The other day I got another email from Brendan on this project, and he said, you know, we need to find out if the problem is actually in the deflection yoke itself, the horizontal deflection circuitry. Is it in the yoke setup? And if it is, we need to find out. So here's what I want you to do. He said, I want you to rotate that yoke 180 degrees. Rotate that baby around. And if that light spot on the screen moves from the left side over to the right side, then we'll know it has to do with the deflection setup, not the CRT itself, or at least pretty much not the CRT, and that'll kind of narrow it down. Even with the yoke turned 180 degrees, the picture of course is upside down, but right now I'm rewinding the tape in the VCR up here, and that gives us a good contrast so you can see how light it is still on the right hand side. It was on the left, it's now on the right. So we're going to have to take that chassis out of here again. Well, as you can see, the old chassis is finally out, and of course, you know, at this stage we need to start checking our various socket connections and values that we have in there that I have changed out. Now this horizontal output, of course, the 6CD6, is exactly where I needed to start first. You know, go there first and then work your way back. We're going to start right here with the 6CD6. We're going to look at all these connections here. Now keep in mind, this chassis originally came out with a 6BQ6 and was later changed to a 6CD6. So, you know, the numbers on the sockets are going to be different, but the connections will be the same. Example, I went over this once before, but I'll show it to you again. The 6BQ6 cathode is connected to pin 8. And over here on the 6CD6, which is the tube we have in there for our horizontal output now, the cathode is connected to pin 3. So 8 has become a 3. Okay, piece of cake. Anybody can do that. So let's follow pin 3 down and make sure we didn't miss anything on all this. So pin 3 will come down off the cathode, and it comes down, 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 and it goes this way, and then it also goes this way through one of the windings in the flyback transformer. Okay, now it also goes the other direction. Let's see where that goes. It's this top line right here, right there. Okay, it comes all the way down, all the way down. It comes up through a resistor, and then from there it goes on up that way, but it primarily connects to this 1.5K resistor. Alright, so let's go over here and start with number 3, make sure we got that hooked right. Well, when I got looking at it, that's pin number 3. Now this is a 4, 3, 2, and let me see, make sure I got this right now. 4, 3, 2, and 1. Yeah. So pin 3 is this one right here. Let's see where it goes. It comes out this wire. Comes out this wire. Well, son of a gun. Look where that pin 3 goes. It does not go to the winding on that flyback transformer. It does not go anywhere. It goes to ground. What? What do you mean it goes to ground? Did they wire this thing wrong at the factory? Is that why I'm not having such a good, success here? See that wire moving? Pin 3 to ground. That does not match up with what's supposed to be. Let's go back where we were. That does not match up with anything like that coming off the cathode of the 6CD6. What's wrong here? Anyway, when I saw that, I'm surprised I didn't notice it before. When I saw that, I contacted Brendan and I said, guess what, buddy? We have a cathode that's grounded, and that's not supposed to be according to the schematic. He said, all right, let me think about this for a while. Well, it wasn't long before old Brendan got back to me, and in so many words, he said, stop. Stop the music. And I said, what do you mean, stop the music? He said, we have been all this time working off the wrong schematic. I said, no, we haven't. You know, it's a Sam's photo fac, and it has the exact chassis number that we have here. He said, I know. But he said, trust me on this, we're working off the wrong schematic. He said, what we need to do is, instead of relying on this Sam's photo fac, we need to get a hold of a Ryder's schematic that's in volume 16 of their television manual book. He said, now it's not gonna be cheap. He said, but we really do need to look on that volume 16 of the Ryder's television manual, and we need to get the correct schematic. He said, I know that there'll be a different schematic in that manual. Well, he provided me a link to a CD where a guy was selling it on eBay. And he was right. It was not cheap. I went ahead and ordered it, though, because I needed it. You know, some things you just got to have. You know, and anyway, it was like $12 for this thing, you know, with shipping it all. But there was a lot of work put into it, you know, putting all of the schematics and the entire manuals for each of these TVs on there. I mean, they go through a whole bunch of televisions on here. And so it came in. And I stuck it in the old computer and fired it up. And lo and behold, what do we find on the new schematic? The Ryder's schematic, which is different from the Sam's for both chassis to be the same. Pin 3 on the 6CD6 is in fact connected to ground. Oh, and one more thing. Up here, this resistor coming off the screen grid on the Sam's photo fac for this chassis, this same chassis now, this is a 1K resistor. Here on the new one, it's a 2.7K. You know, I remember I remember when I first worked on this the socket for this tube, I noticed that this thing up here, I think it was a 3K resistor they had in there. And I remember thinking, boy, that's dumb. Somebody put a 3K resistor in here, and according with this, you know, the Sam's PhotoFac, it's supposed to be a 1K. So I took the 3K out and put a 1K in there. Guess what? I had to order some new 3Ks today because I'm going to have to put the 3K back in. Anyway, that's what's going on. We're going to have to, you know, get everything set back up in accordance with the new schematic. You know, I tried to tell Brendan about this. You know, I said we probably have the wrong schematic, and he said, no, we're okay. I said, no, we do need to go with a different schematic, maybe a rider schematic. That's what we got to do. You know, maybe volume 16. You know, and that'll maybe give us the, you know, the straight poop on this, because too many things are not matching up. Now his story may be a little bit different from mine on that, but you know, the point is, we're going to go ahead and do that. We're going to get things all straight, you know, squared away down around here and anywhere else. Another thing, 145 volts coming out of the electrolytic capacitor, the one on the Sam's PhotoFac, is 140. Small potatoes, but you know, I mean, there are differences between these two. So we're going to do all that next time. I'm going to have it all done. We're going to go ahead and turn I'll have an extender cable made for the CRT. I've ordered something in. I'll show you how we're going to do that. And we'll take care of it all then. So until then, until next time, I guess is what I should say, this is John.